examined a series of data some years ago that John Widmoroppy had obtained from the measurements in the literature. He had over 300 literature citations for all the different ages in the strata. And I did a correlation, a time correlation of all those individual measurements. And every one was done by at least 3 different techniques. And you had errors over those spans of time exceeding well over 100% in most cases. So if you have errors exceeding over 100%, you have nothing to correlate from the beginning to the end. The best errors, or let's say the least errors, were the ones for the Quaternary period, the most recent period in geologic history, which would have been like 25 or 30% error, presuming all those presumptions that have to be made were true. But we know what? That they're not true, right? So even so, it still doesn't mean anything in the long run. None of those presumptions can be reasonably true, either by chemistry or by physics, in my way of looking at it. I think geologists better learn a lot more chemistry and physics before they start making claims about what they're doing, you know. I don't want to insult geologists. Geologists are good people. I mean, I'm saying the techniques that geologists use invariably are very much subject to chemical laws and physical laws. And you can make these assumptions, and you have to make them. Why? Because if you don't make them, the measurements mean nothing. That's why. So you either make the assumptions and try and give a valid reason why they might be legitimate, and accept that, and then draw your conclusions. But if you don't make the assumptions, you don't have a chance of getting any results at all, right? I mean, that's just the way it is. I'm not being critical of people. I'm being critical of methods, of methodology and interpretation. Anyone else? Bill?
Could you briefly describe the mechanism of this incredible cooling event where we go from plasma to a crust in 14 hours? Where does all that energy go?
See, remember, we're just dealing with the Earth as an isolated entity. Creation involves a lot more than just the Earth, right? So, all that energy is going out. It's radiating out. It's got to be radiating out. And, we got a lot of space to radiate it, for sure. And it nowhere comes near to the energy of the total universe. I mean, it's just a drop in the bucket compared to the energy of the total universe. So the idea is, based upon the expansion laws, that as you cool, the size contracts, and of course, as you heat, the size expands. And it's just simply expansion laws that have been applied by cosmologists to expansion or contraction of the universe. But you can do the same thing with an isolated sphere, like the Earth, Now, I don't really necessarily like that approach too much. I think I got much better results using Laplace's cooling equations and putting in some meaningful numbers and getting the results that way, and you come out with very short time for the cooling process. Either way you look at it, it cools fast. Well, from when the plasma started. I don't know what God did in day one, how long he allowed his water to stay water, before he converted it. But I presume the same thing would have been done for planet formation. I don't believe for a minute that planets happened out of, spewing stuff out of the sun and all of that. I mean, that's another mechanism for forming the Earth, right?
So you're proposing there was water or crust because the parent material was there, then there was an influx of energy that turned it into a plasmoid state.
And then
the radioactive decay occurred, then there was this amazing cooling event that put it into the present form. So
right. But remember, all the elements were formed initially in that condition. And then as they cooled off, they formed their molecules and their compounds, right? I mean, that's another problem, trying to see how the molecules and the compounds, and that's what I think is an insurmountable problem, that you really can't deal with that problem.
this into the creation week so that when God created the sun, moon, and stars
Mhm.
on day 4, but he separated the waters on day 2. So if this plasma took place on day 1, part of the energy was spread out there on day 2. Then he went back to the earth and put the land, brought the land out, which is all that part of the same.
Well, that's the cooling process.
Yeah,
Yeah, that's the cooling process, right.
But you already put in the seed-bearing trees, plants, and grasses on day 3.
Oh, yeah, all the water didn't leave.
And then
Yeah.
on day 4, he took that, whatever he'd thrown out there, created the sun and stars.
Yeah, but it didn't all come necessarily just from what went on in the earth.
Well, I just mean,
God had a lot more water in the universe
just
than,
saying that's,
yeah,
that's the sequence.
yeah, that's a sequence, yeah. Day 4 would be that other aspect of everything else, yeah. And I believe that each planet would have had a similar mechanism, you know. Each planet would have had a similar mechanism. And what results depends upon how far, you know, all the environment that they were undergoing. And, you know, why would say, Jupiter have certain composition that's so vastly different from Mars or Mercury or Venus? You know, the terrestrial planets are somewhat similar, right, in their chemical composition, but the further out you go in space, those other planets are what? They're not quite the same as far as we believe the analysis by spectrophotography, you know. I don't always believe spectrophotography is absolute either, but it's the only thing we have, you know, to get any
So
numbers.
you're saying on day 1, God created the heavens and the earth,
That's right.
and then the sequence is there, but the same things could have happened out in space.
Yeah, see, day 1 in Hebrew, and I'm not a Hebrew scholar, but I've learned this much, that there's a word, if somebody knows what the word is, but when a statement is made of the beginning and the end in the first, this is what we're talking about. First sentence, right? There's a Hebrew word for that, and I don't know what it is, but it's something in Hebrew literature that's done rather commonly, as I understand it. So we can't start dissecting that first line of Genesis, say in the beginning God created the heavens and the earth, and become a gap theorist. You know, that's where they got into trouble. They said, oh, there were 2 creations. You know, oh, heaven and the earth was created, first line, Genesis 1. Baloney. That's just a device, a literary device in the Hebrew to say, here is what's going to follow. We're talking about the heavens and the earth being created. That's what it is. It's not a statement that, you know, in line 1 that heaven and earth was already created.
I'm trying to understand the plasma on the earth, whatever plasmas that were on the other things that were.
Well, any state that would have been activated energetically, like the earth was activated to form the elements and so on, would have had to been subject to the same kind of environment, same type, essentially, same type of plasma. In fact, the sun, the stars, the plasmas of those environments are still plasmas. They have never cooled off to anything else. Now, they've cooled